Hello everyone, this is Rikza Awan and I'm an agronomist, MSc Honors and Agriculture Specialist. Nowadays I'm working in SAWiE as a head of outreach and somehow I'm also heading commercialization in SAWiE. So this is my brief introduction. Now I'm going to start this event formally. Here we got Dr. Muhammad Imran. He is lecturer in mechanical and design engineering. He's established researcher in the area of thermal energy system. He's also working in the area of waste heat to power conversion technologies since 2012. Now, I would like to request Dr. Muhammad Imran, please give introduction and welcome note to our audience. Thank you so much. Welcome, Mr. Muhammad.
Thank you very much. Thank you everyone for joining for this event. My name is Imran. I'm working as a lecturer at Aston University since 2019. As Ka already mentioned, my background is in area of thermal energy. I have been working mainly in energy efficiency, renewable energy, and thermal energy systems since 2012. I have the opportunity to work in Asian countries, including South Korea, then moved to European countries, worked in Netherlands and Denmark, and finally I have been working in Aston from last 3 years. This project is a part of one of my projects with developing countries. This project was funded by um, uh, under GCRF program by UKRI. The main purpose of this funding was to develop a networking collaboration between developing countries, and the funding was managed by Academy of Medical Sciences, UKRI. We have got another funding with another developing countries in Kenya. So we have in parallel two grants. The major primary aim of this funding was to have a networking grant on one of the key topic of mutual interest of developing countries with UK and explore the opportunities where we can build on our collaboration for further research grants or research collaboration. Um, this particular project focus on biomass energy, which I presume is one of the largest share of energy in Nigeria. I think in total, if we consider the final energy usage in Nigeria, that is around 160 tons of oil equivalent, and about 40% of that comes from bioenergy and biomass, and which is also a major source for cooking in Nigeria. In terms of access to electricity and clean cooking, I think about 45 to 55% of population in Nigeria does not have access to clean cooking or electricity. So the primary aim of this project was to develop some sort of assessment tool for biomass energy in Nigeria that can be used to assess how much potential is locally available in different geographical locations in Nigeria that will enable to have a proper planning of energy systems, demand and supply management, and we can identify appropriate route of biomass energy conversion, which is more suitable depending upon the availability and feedstock of biomass in different locations. Yeah, it was a short project. It was not a large amount of funding. It was just networking grant. So that was supposed to only have workshops, travel arrangements, and explore further funding opportunities. We are lucky enough that through this project, we extended our collaboration and we have now two further grants with our project partners from Nigeria through this networking grant. It was awarded in 2020 for 1 year. Due to COVID-19, we could not avail the travel opportunities and resources that we needed for this project. So we extended it for 1 more year. It will officially end by next month, but we will continue our collaboration with these partners. This partners, this project also involves number of universities and industries across Sub-Saharan African region, including Kenya and Ghana. We have active partners who are working in biomass and bioenergy. Um, this workshop is mainly regarding the biomass and bioenergy potential in Nigeria. The second workshop that will be held tomorrow will be focus on how we can assess and map biomass and bioenergy using a GIS mapping tool. So I will leave it to now, Aksa, I think this is a brief introduction of the project and myself. If you have any queries about the project and any questions about collaboration, please feel free to write me. And again, feel free to introduce and discuss among the participants of this workshop. I think we will have panel discussion where you can have the opportunity to ask the questions to the panel members, and feel free to write to us if you have any collaboration ideas or you want to discuss anything. That's all from my side. Thank you, Aksa.
Thank you so much, Mr. Imran. Welcome, everyone. People are just joining us. The next speaker will be Dr. Muhammad Sagir, Director, CEO, Eco Research Limited, UK. He will talk about an innovative UK-funded project, a case study of waste to energy feasibility study for a small-scale gasification system, development for Pakistan. Welcome, Mr. Muhammad Sagir Saab.
Thank you. Just give me a second to. Actually, you need to enable me to screen share.
Okay, let me. You're a co-host. You can share your screen. I'm making you during your lecture. Now you can check. Are you able to share your screen now?
No, not yet.
Okay.
Yeah, still not. It says host disabled participant screen sharing.
Let me check this again.
It's Muhammad Sagir just after Simon. You should just see below Simon here. Just right click on the top. There, just usually you can say.
Are you able to do so, Muhammad Sagir Saab?
No, not yet. I'm still waiting, actually. Still disabled.
So you have to usually go onto the top of the name. So it's Muhammad Sagir. So just choose the option more, and then there's option to co-host. You did for me as well.
Host.
No, I'm still unable to share it.
Sagir Saab, do you have any presentation?
I do have my presentation, yes.
Okay, you can share that presentation to Dr. Khalid, and we can share our screen on your behalf.
Okay.
So it isn't letting you to do so, Riksa?
Yes, sir, we can.
Is it not helping, not allowing you to do, because usually you could do it. So maybe Hanan, you want to guide?
Yeah, actually, Dr. Muhammad Sagir Saab is meeting.
So Sagir, maybe if you send it over to me, maybe WhatsApp or anything, then I'll just.
Okay, 1 second.
Aksa, sorry, Riksa, apologies, I was calling you in different name, but I think if you remove me as a host, you can allow, I think maximum 3 or 4 people are allowed host or co-host, so you can remove me and add Sagir as a co-host.
Okay.
Yeah, remove me and add him. I think it will allow.
So actually, Imran, you are host. That's why it's showing up. So Imran, you can make co-host others. Yes, Imran.
Okay, let
yes,
Dr. Imran Saab, please make me a host. Then I can change.
Yeah, sorry.
Okay, I just allowed Sagir to host now.
Yeah,
Sagir, you will be able to do now.
Yes, I can.
Yes.
Excellent. Thank you.
Technology fixed. Oh, good.
Some flaws of technology.
So it's I think it's really good to see a lot of people here. So yeah, maybe we should introduce ourselves in the chat box as well. Yeah.
Yes, I think that's a good idea. We have a good number of collaborators from Nigeria as well. So maybe one line introduction from where they are and what they are doing, expertise. So
Can you
use
see my
shared option.
screen?
Yes.
Okay. Sorry. Okay, so hello everyone, and Assalamu alaikum to those who can understand the meaning of it. My name is Dr. Mohammed Sagir. I'm CEO of Eco Research Limited. It's a small R&D company based in UK. While running this company, I'm also working in Keele University as a research and innovation and leadership development manager, where we work with small and medium enterprises. My presentation is waste to energy, a case study for a small scale gasification system development for Pakistan. This study is actually based on small funding which we received to conduct the feasibility study from Innovate UK, and we completed this study. I will have a few things going to be presented later on today, a little bit of a personal biography, circular economy, biomass types, biomass energy potential, challenges with biomass, and advantages of bioenergy, and state of the art and polygeneration through gasification, and small scale waste to energy system model for Pakistan. And then I will have conclusion. I'm not sure if you can see all my slides, how to move this. Okay. Maybe this is better. So I did my postdoc at University of Birmingham, working on a Horizon 2020 funded project called FlexJet Fuel. I did my PhD at Energy and Bioproducts Research Institute at Aston University in 2018. And various other qualifications, for example, Bachelor in Chemical Engineering, and I've done my postgraduate in Chemical Process Technology at Aston University. And as I said, quite recently, I'm working as a Research Innovation Leadership Development Manager. I have been a key resource in deploying 7 megawatt smart energy network demonstrator at Keele University, where we have 12,500 solar panels and 2 wind power generators, which we installed to integrate in about 400 buildings of Keele University. I was also a plant manager for 1.4 megawatt bubbling fluidized bed gasification plant at Ebri or in Aston University. Okay, so the technology we are working on actually obviously addresses mostly the energy related sustainable development goal, which is SDG 7, but it also have quite indirect link with a lot of other sustainable development goals. So for example, no poverty, good health and well-being, which is linked to clean cooking by using syngas. Gender equality, again, through clean cooking. Clean water, we can use the same energy to actually do water desalination or filtration by reverse osmosis. Decent work and economic growth, we can provide jobs. We can also do responsible consumption and production through SDG 12. Definitely SDG 13, where we can address climate action. Where we can obviously displace fossil fuel usage and also reduce the carbon emissions associated with degradation of biomass when it's left to rot and pollute the environment. And we can address the SDG 15 through protecting life on land by complementing biomass production. So biomass and circular economy, I mean, it's no-brainer. Nearly all of us are quite familiar with the bio-circular economy concept. But here there is a little bit of a model which you can see. We obviously, if we are growing the biomass, we are absorbing the carbon dioxide from the atmosphere. and solar energy together with the water in plants and a lot of other micronutrients bring this carbon back into the circular economy, and we can use it in many different ways, such as biofuels. We can use it as construction material. We can use it in food production and so on. And all these activities lead to a lot of waste generation, which sometimes is left to rot, and we can actually use these materials to our economic benefit. So type of biomasses which we have, you can see there are lots and lots of types here. Obviously, I haven't put down every single thing. You might have some very unique type of biomasses in your country. For example, in Nigeria, there is cassava, there is palm, and a few others, but I think I have represented most of these here. All these can be used in many different technologies, but also in gasification technology, which I will go through a little bit later on. So the challenges with biomass are multifaceted. Obviously, there are operational challenges in terms of low dispersion of biomass, low density, weak supply chains or no supply chains in some instances, and inefficient conversion technologies. There are economical risks and challenges, obviously feedstock cost variations, seasonal availability, and so on. Social challenges in terms of competition for uses of biomass, whether we should use it as a food or fuel, and there is a big debate, but we are trying to focus in an area where bioenergy production is complementary to the food production, so that we are not competing with the existing food uses and land uses for the biomass. And obviously there are regulatory challenges in terms of having very limited policies and support mechanism to deploy bioenergy projects. So when we look at biomass, obviously biomass is coming in many different ways and forms. Sometimes it is very smelly and low-grade material of high moisture content, and nobody wants it. In fact, you may have to pay to get rid of it. And all the way up to the right-hand side, where you can see there are standardized products. For example, there are pellets, there are chips, there is timber, where you have added the value to this biomass, and each one of them attracts a different value, and it has different calorific value. So I have represented on these horizontal axis, calorific value is quite low when the biomass is unprocessed and it's wet, and its value is negative. You have to pay to get rid of it. And as you add value, you standardize it, you separate it, you shred it, you pelletize it, and then you sell it. Obviously, you're increasing the calorific value, but also you are increasing the cost, or you are adding more value to it. And this is the way we can utilize the biomass. Otherwise, biomass has literally no energy, no value, sorry. Biomass to energy in Pakistan. Pakistan is an agrarian country, huge biomass potential. We done a lot of research on this through the Innovate UK funding, and we identified crop residues in excess to 62,000 gigawatt hour per year of thermal energy potential. Crop harvesting residues, 114 million tons per year. Huge, I mean, numbers there. And obviously there is animal manures, livestock waste, and municipal solid waste, mostly, for example, where your biomass and plastic and other materials are mixed together. So we identified that there is a huge potential, and there are a lot of different energy pathways which we can utilize to actually enable the usage of this biomass and convert it into some sort of end products which have high value addition, but which have needs, which have demands in the conventional market. So for example, through obviously thermochemical conversion, we can produce all sorts of heat, electricity, chemicals, bioalcohols. Biochemical, we can produce bioalcohols and chemicals, and direct combustion, which is there since caveman. This is still ongoing, and we can still make use of this. In terms of technology selection for biomass, we have 4 or 5 kind of very high level technologies. Obviously, there could be much more than this, but very small scale are now well known. Anaerobic digestion is quite well known, pyrolysis, gasification, combustion, and transesterification. All these give different end products. And that means if your end product is just one, you are stuck with that end product. For example, through combustion, you can only produce heat. And if you are producing heat, then you either use that heat to drive a steam turbine and then produce electrical power. But if you are doing gasification, you have a syngas as an end product, which can be used in power generation, but also it can be used in chemical synthesis. You can produce biohydrogen, you can produce bioethanol, biomethanol. You can also produce something called dimethyl ether, which is a condensed fuel in the form of ether molecules, which can be used as a LPG replacement. So all these have different end uses, but also their working temperature and the type of feedstocks they can use, it varies. And you want a technology normally where you can have multiple end uses, but the technology itself can use multiple different types of feedstocks or biomass feedstocks. I will highlight this issue later on. You will see why it is important that we have multiple different feedstocks to be used in the same technology. So in terms of end products, we can obviously densify the biomass by pelletization or briquetting, and these can then be fed into conventional thermal energy systems, for example, boilers and so on. We have advanced thermochemical conversion through pyrolysis, where we can produce a whole host of different products: biocarbons, biocoal, activated carbon, bio-oil, biochar, syngas, and so on. Similarly, with gasification, we can produce syngas, which can be used in many different ways through an engine, gas turbine, boiler, kiln, and so on. And even solid oxide fuel cells can be run on the syngas. Anaerobic digestion, as I said, it's quite well known and famous nowadays. And there are a lot of different types of biofuels which can be produced from the biomass. So in terms of a working model, if we look at a system which can give you multiple end products and you can maximize the biomass utilization and conversion into some sort of product and maximize the value addition. So there is one little model which is here based on anaerobic digestion, but it can also be based on, for example, pyrolysis or gasification or some other forms. So literally here, what we are saying that we are able to address many different end user needs, but also we are able to use quite a few different types of biomass. Mostly in this case, we can use agri residues and livestock waste. But if we change the technology here from anaerobic digester to, for example, biomass gasification system, we have much more diversity of feedstock which can go in, but also diversity of products which we can produce. Obviously, through syngas, we can do clean cooking, we can produce heat and power, we can produce chemicals, we can produce a dimethyl ether which can replace LPG. So bioenergy, carbon capture and storage, BACS, this is a new term which is being used and it is quite popular, and it tells you what it is. So 100% of the biomass, for example, is being utilized in pyrogasification system. Some of it is taken out in the form of 50% carbon in the biochar, and the remaining energy is then taken to be used in either transport or in conventional heat and power or in industry. And biochar at the same time can be further upgraded through other mineralization techniques and so on. So state-of-the-art pyrogasification technology is in development. A lot of different companies, institutes, and countries even working on this kind of technique where you can actually utilize a big variety of crude biomass, which is of no value at the moment, or people have to pay to get rid of it, and how to produce an end product which is kind of standardized and can be used by many different end users or in many different industries. And through this technique, we are able to, for example, increase the material energy efficiency up to 80% by using also or by recovering the heat. For example, heat can be used for space heating or cooling, but also it can be used in many different industrial processes or for water desalination. And we can achieve waste minimization more than 95%. So one such advanced system or state-of-the-art system which we have installed or I was part of, this is 1.4 megawatt pyrogasification system which we installed at Aston University in Birmingham. This system is spread on 3 floors, and you can see various different components which are shown in 3D image here. It has a gasifier, it has a pyroformer, which is a pyrolysis reactor integrated with the gasification system, where we are producing the syngas, and syngas is cleaned and cooled through heat exchanger and scrubber system, and then it is used in the engine to produce heat and power. A similar system has been developed by Technical University of Denmark. Its system is called Viking gasifier, and this system is very advanced. It has very high energy conversion, but also it has very high tar conversion. Tar is some sort of a hydrocarbon which has molecular weight greater than benzene. And by doing this kind of pyrogasification technique, they are able to reduce the tar content down to 5 milligram per meter cube of the syngas. In conventional gasification system, this can be as high as 500 milligram per meter cube, which means the tar is going to condense in the system, and it's going to cause a lot of problems in the turbo machinery, in the fuel injection systems, in the pump, and so on. So by converting tar, we are converting more hydrocarbon into simpler hydrocarbon to produce more energy, but also reducing the likelihood of problems. So a similar system is being developed by us. We are working on a similar system. The case study for waste to energy, we have initial project development activities completed where we developed the business concept, we registered the company, we conducted the feasibility study, and we are in the process to raise the seed equity. Develop the project, which is the second stage. We are developing our business plan. We selected a site in Gujranwala where we are going to deploy our technology, and we are working to actually secure the permits and also the legal formalities to ensure that we are not going to get in trouble with local authorities. And obviously later on, we are going to do a lot of extended testing and then scaling up the project. And then we are going to execute it on a mass scale and implement it in Pakistan. So project phase 1, obviously here you can see that the red box here, this is where we have concentrated at the moment, where we are taking the biomass, we are drying it or shredding and pelletizing it. Then we are converting it into syngas, and after syngas through a small filter, then we are taking it directly into a furnace or a boiler of some sort, so that we have less steps of processing and less capital involved, and direct utilization of the syngas on site. I mean, we can also go through the second stage, which is the blue box here, where we can clean the gas much more in detail, where we remove the tar, we remove the dust, we remove the water condensate, and so on. And then we use the syngas in either CHP or a gas turbine, or into, for example, solid oxide fuel cell, and so on, and we produce electricity and heat. But here, more capital is needed, more processing steps are involved. So we have rather focused at the moment mostly just for direct combustion of syngas into existing machinery. For example, a lot of kilns, furnaces, and boilers can use our technology. We have already built a small proof of concept which works at 20 kilogram per hour, and its processing conditions are anything between 800 to 1000 degrees Celsius. It can work around 100 millibar pressure. It can use a big variety of feedstocks. and we have already a good understanding of our tar and syngas composition. So in terms of technology itself, we are working on a fixed bed reactor co-flow system, as opposed to a lot of other technologies, for example, counterflow, stationary, and circulating fluidized beds. So our technology is mostly fixed bed system. In terms of biomass supply chain and deploying a biomass energy project, we need to establish the biomass supply chain, because without this, your project is not going to be successful. So there are various different stages of this involved. So for example, collection of rice straw and then transportation and storage of the rice straw. For example, we taken a rice straw in here as an example. So we need to collect the residue, then we need to transfer it from the field into some sort of interim storage. And from there on, we either want to, for example, pre-treat it in terms of briquetting it or pelletizing it so that we can increase the energy density and then transport it to the end user location where we are going to install the plant, and then we use it there. So harvesting, collection, and pre-treatment is one. Storage is another thing which we need to look at, transportation of the biomass, and then energy conversion. So there are a lot of different activities involved in each stage, which I have explained here. Obviously, we need to ensure that we have some sort of contract with the farmers. We need to have some sort of local storage of this biomass, and then also we need to have the ability to pre-treat it there. So for example, densification in terms of pelletization or briquetting and so on. And then we need to form a network where we can organize the transportation of this material to the end user location where we are going to convert this through pyrogasification into syngas. In Pakistan, we identified there are certain areas where we have very high density of the biomass. So these red circles actually give you the locations where we have concentrated our efforts, and later on you will see results from here. So we can see that in some areas of Punjab here, there is a high biomass density around Gujarat, Gujranwala area. And then we have around on the border of Sindh and the Punjab, a lot of different districts have a very high density of biomass here. I will give you a little bit breakdown of these later on. If I can move this here. So here we have shown the quantity in terms of a local unit called man, and 1 man is 40 kg. So what we can see here in Faisalabad, we have more than 200,000 months of wheat biomass available as an excess material. Likewise, in these areas here, Bawalpur, Rahim Yar Khan, Bawal Nagar, Vihari, and so on, we have very high energy density of wheat biomass. If I can, cotton biomass, we identified areas, for example, Bawalpur again, Rahim Yar Khan, Bawal Nagar, very rich with cotton stick, and this biomass is another very high lignin containing material which can be used in gasification processes. We can see it's more than 1,500,000 tons or more in these areas, which is available in the season. In terms of sugarcane bagasse, Rahim Yar Khan is very abundantly enriched with the biomass from sugarcane bagasse. 700,000 months of this biomass is available. Faisalabad, Sargodha are the next best candidates. In terms of rice husk and rice straw, we saw that Gujranwala, Nankana Sahib, and few other districts, for example, Sialkot and Gujarat, have quite a lot of rice-based biomass available, both rice straw and rice husk. So all these numbers and regions, when we aggregate it together, because we need to see the biomass availability around the year. every month of the year, if we can get the biomass available, we can support a massive deployment of our technology in those areas. But at the same time, there need to be high demand for the gasification processes or industries which can use our gasification technology in those districts. So we saw that Raim Yar Khan, Muzaffargarh, Raim Yar Khan, Vihari, Bawalpur, Faisalabad, Jang, and so on. All these districts have very high potential for biomass based gasification plant deployment. And you can see the residue collection months here. So for example, the Pak Patani is one of the area where we have quite a huge availability of biomass here. And this is available more or less 6, 7, 8 months of the year. And with a little bit of storage, we can use these biomass in those districts. Gujranwala is another biomass where rice straw is abundantly available, rice husk is abundantly available, and there are rice mills already installed where we can add our gasification plant, for example. So in terms of end users of our technology, we identified that there are a lot of sanitary ware manufacturers where they are using LPG gas to actually run their processes. Sometimes they don't have natural gas pipeline or natural gas grid connections, or they are remotely located industries that gas lines are not installed anywhere near to them. A lot of porcelain manufacturer companies which are concentrated around Gujarat and Gujranwala regions, they can also make use of our technology. Steel mills, rice mills, textile mills, cement industry, thermal power plants, food factories, and a lot of other boiler and furnace-based industries can utilize our technology, where either they are conventionally burning coal or LPG gas or natural gas. And natural gas is already kind of running out in Pakistan, and Pakistan is looking to diversify what else is available for their problems with the natural gas supply. So in terms of business model, we are looking to attract a small investment of let's say $100,000, which is about Pakistani 20 million, to set up our first demonstrator plant of 50 kilogram per hour, where we can test a big variety of biomass feedstocks and conduct a detailed techno-economic analysis. And then with the partnership with the biomass feedstock suppliers, engineering manufacturers locally, and end users and investors, we are hoping that we will deploy our first 10 examples in the country. So we have looked at 50 kilogram per hour and 250 kilogram per hour plants are kind of ideally suited to the small scale industries within Pakistan. And these systems will be kind of modular units which we can deploy in mass numbers. They will be manufactured in a factory, and they will be deployed as a business model based on B2B, build, own, and operate model, where we will own and operate the system ourselves, and we will be selling the syngas or heat to these industries. And I already talked about this. We are looking at our business model where we can achieve break even in less than 3 years. And our system will cost, a small system will cost about 18 million Pakistani rupees, which is about $90,000. And it will consume 360 tons per annum of biomass, which is quite a small number. In terms of traction, so far we have obviously done a feasibility study. We have filed our patent. We are waiting for our patent to be granted, and we are working at the moment to get some sort of regulatory approval from Pakistani authorities to deploy our system. And we are trying to bring some investors on board. And we have seen that there is potential for nearly 10,500 plants of such scale to be deployed in Pakistan. And even if we have about 5% share for ourselves through this biomass to energy market, we can deploy 10,500 plants, and we can create about 31,000 new jobs, and we can strengthen another 1 million existing agricultural related jobs, because they will now be collecting the materials for us. They will be processing it, transporting it, and they will be running our plants. They will be maintaining and so on. In terms of summary, bioenergy is an ideal kind of asset for Pakistan. As an agrarian country, rural development and biomass value addition can be achieved through biomass-based energy system. Advanced thermochemical conversion technologies are ideal for utilizing complex residues to produce energy. We have huge flexibility of the feedstock in Pakistan. We have the technology which can use that big diversity of feedstock, and we are able to address multiple different sustainable development goals of United Nations by utilizing those biomass and addressing the economic development impact. I think that's it from me. Thank you very much. And if you have any questions, I'm ready to take those questions.
Thank you so much, Dr. Mohammed Saghir Sahab. This was a really fruitful presentation and very brief presentation. Thank you so much again. Anyone wants to ask question from audience? Please, you can raise your hand. It's a question answer session. You can ask question from Mr. Imran, from Mohammed Saghir Sahab. I think.
Thank you. Yeah, that's fine. Thank you. So maybe later discussion we will have more.
Okay, thank you so much. Again, I want to say, if anyone wants to, want to ask any question, then you can write something. You can write a question in comment box as well. Okay. The next one is also a very prestigious personality, Mr. Simon Iofos. He's a co-founder, CEO of Pyrogenesis Limited. He's a co-inventor of the pyrochemy waste to energy containerized technology, which simultaneously converts agriculture waste to renewable electricity process, heat, and biofuel. I would like to request, again, I'm saying he's doing a great job. I would like to request Mr. Simon Iofos, please speak about why pyrolysis is the answer of bioenergy and biofuel production in Nigeria. Welcome, Mr. Simon.
Thank you very much, Rigsa. Can you hear me okay, everybody?
Yes, we can hear you.
Okay. All right. I'm presently in Abuja, and my internet connection has been a bit flaky. It's been going up and down. So if I drop out, I will reconnect, hopefully. So yes, thank you very much, first of all, to the organizers of the event and the funders for inviting me to present today. I'd also like to greet my co-inventor, Dr. Mohammed Saghir, co-inventor of the pyrochemy system, which is a pyrolysis-based system that I'm going to tell you a little bit about, and how I feel that fits in very well with the Nigerian system. So I'll just try sharing my screen now. Okay. Can you tell me if you can see my screen, please?
Yes, we can see your screen.
Okay, so this is, okay, so you can see my slides. So yes, why pyrolysis is the answer to bioenergy and biofuels production in Nigeria. As I've been introduced, I'm the co-founder and CEO of Pyrogenesis and co-inventor of the pyrochemy system. So I'll tell you a little bit about our organization at the moment, Pyrogenesis. We are a UK bioenergy, biofuels, and carbon removal technology provider, and we focus on enabling rural communities and agri-processors to valorize their various underutilized wastes by converting them into renewable energy, biofuels, organic fertilizer, and carbon removal. So our name, Pyrogenesis, and our motto, all things work together for good, really embody our mission. So what is our mission? Well, we seek to integrate this very powerful patented pyrolysis technology, which we call pyrochemy, with complementary technologies. And Dr. Saghir has just explained to you about pyrogasifiers, which is one such integration. And we're doing these integrations to develop circular economy systems that create value from combustible waste materials. So Pyrogenesis as an organization puts waste to work for the purpose of producing good outcomes in terms of energy access, value addition, and carbon removal in a way that benefits base of the pyramid communities and rural industries alike. So this is a photograph of our pilot unit, and it's a pyrolysis system, as I mentioned. And pyrolysis, for those who are uninitiated or not aware, is an advanced thermochemical conversion technology. And of course, alchemy is a process that converts base materials to higher value commodities. So that's really going to use a very powerful technology to help these rural communities and rural agri-processors add value to something that they have an abundance of, but at the moment really have not much use for at all. And therefore they have no value, either next to none or little value at all. So this is an overview of our pyrochemy process, which produces bioenergy, biofuel, fertilizer, and carbon removal. First of all, we start with, as a feedstock for pyrochemy, we use harvest and agri-processor wastes. Now, the reason that we use wastes is so that we do not compete with land usage for food production. Whatever we take is literally something that's either going to be thrown away or worse still burnt. So it's either going to rot, creating greenhouse gases one way or another. And that's what we would typically, maybe in some cases, we need to do some pre-treatments that Dr. SAWiE was telling you about. In some cases, we don't have to at all. We can just put it straight into the machine. And that's the pyrochemy system here. So number two, really what comes out of our system as a way of an output, we always produce a biochar. And this biochar, we can treat it with developed treatment methods to convert it into an organic fertilizer, which we've trademarked as NutriChar. And NutriChar, when it's applied in an agricultural or horticultural application, i.e. it's put back on soils or used as a growth media, attracts carbon credits because we've effectively created a carbon removal system. So soil sequestration of biochar will result in carbon removal. An alternative route is that we can use it as a smokeless fuel because it effectively acts as a coking process, removing the volatiles. And so therefore, when it's burnt, it doesn't produce much smoke, if any at all. And therefore, it can be used in clean cooking stoves, and clean cooking stoves also attract carbon credits. Alternatively, not alternatively, what we're always seeking to do is either generate renewable electricity, renewable heat, and also low carbon cooling. So we can get any one of these outputs from our system. If we're not doing that, the calorific value of what we produce in the vapor phase through the pyrolysis system, we can actually condense into a bio-oil. And working on various projects with our project partner at Aston University, we have developed a method, or rather they have helped us develop a method for upgrading that bio-oil into a renewable kerosene. And so that kerosene can be exported from these communities as a commodity, and therefore gives these communities a way of adding value to their waste. We can also use the bio-oil as a fuel storage to put it back into our system as well. Now, in the Nigerian context, why is this kind of technology really important and significant? Well, this map on the right that you see here is a map that was produced by the Rural Electrification Agency, who conducted an energy access survey of around 8,000 off-grid Nigerian communities. So each one of these green dots here represents an off-grid community in Nigeria. And the Rural Electrification Agency have secured $550 million from the World Bank and African Development Bank to pay for and subsidize the cost of electrifying 10,000 communities. So this represents less than 1/3 of the actual demand in Nigeria. They couldn't survey all of the communities. And if we put it into context, about 51% of Nigeria's population currently live in rural areas that are far away from the national grid connection. So that's above 10, sometimes even 20 or 25 kilometers, yeah? So this means that there's over 80 million people in Nigeria's rural areas that don't have access to electricity. Now, when we look at what that means as a commercial opportunity, if you develop an off-grid alternative that's going to complement the grid, there's a $9.2 billion per year market opportunity for you in Nigeria. It's the world's largest mini-grid market, as confirmed by the African Development Bank. So They need technologies. At the moment, solar PV is really doing a lot of the work. No other technologies really. Sorry, I don't know where I dropped out. Can you let me know which slide I got up to? Can you hear me?
Yeah, I think when you were discussing about the mini grid capacity in Nigeria.
Okay, was that with the map as well?
Yes. Yes.
Okay, so you could see this map here, yeah? Okay, can you see this? Can you see my slide?
Yes. Okay.
Can somebody confirm, please?
Yes, we can see it. I can see it.
I won't know whether I've dropped my connection until it literally times out on my computer, which is just what happens. So can somebody confirm if you can see my slides?
Yeah, we can see your slides, Simon.
Okay.
Yeah, we can see your slide. Can you hear us?
Simon, I think there's internet connection at your end, because we can see your slides and we can hear you. You may continue, please.
Okay, yeah, sorry. I'm just going to try and connect again. It just dropped out again. Unfortunately, this is one of the problems of, yes, another problem of the situation in Nigeria is it's not just the energy supply, it's the internet access as well. But I think the two are affected by each other. So yes, if we improve the stability of the existing grids, hopefully we'll improve the quality of the internet connection. So I don't know if you heard where I was saying that 51% of Nigeria's population are living in rural areas, which equates to 80 million people who don't have access to power at the moment. And if you're going to develop a solution to this problem, the problem itself represents an opportunity worth $9.2 billion a year for anybody developing a mini-grid application in Nigeria. This is financed by the World Bank and African Development Bank, and there's a lot of other funds that are moving into this space as well. So Nigeria is the world's largest mini-grid market, as confirmed by the African Development Bank. And so it's therefore a very interesting location to do business if you have a technology like ours that converts agricultural waste to renewable electricity. Okay, just move to the next slide. Right, so if we're looking at energy demands versus biomass availability, what we see is that I mentioned a lot of these communities have an abundance of waste biomass. And so why is Africa in darkness? And you can see all these other areas lit up like a Christmas tree. Well, basically that represents a failure living in darkness. I'm living with this at the moment. The electricity could go at any moment. You'll probably see, you'll notice if it happens. Now, it's ridiculous because we did some work with the University of Leicester to survey those 8,000 communities that were on the Rural Electrification Agency database. And what the survey came back with, we were looking at, well, how much biomass do these communities produce that are off grid? And how much do they need of that biomass to meet their entire energy demand? And this graph here on the right shows you, I mean, look at this, 2,000%. So that means, you know, most of these communities produce 20 times more waste biomass than they actually need to generate their entire energy demand. And what that equates to effectively is that they can become net exporters. Okay, so it's not really easy to export electricity because you need to put in cables and pylons and everything else. It's not easy to export gas because you need to put in, pipelines. So you might as well export biofuels. And that's why we developed our technology to be able to convert this waste into biofuels, as well as the electricity that they need for their local consumption. So that's why you would use pyrolysis rather than, say anaerobic digestion at one of these locations. And then the other thing is that all of these different locations, they're using all sorts of different types of feedstocks. So as everybody knows, and Dr. SAWiE will confirm, gasification is very feedstock inflexible, whereas pyrolysis is the opposite, it's feedstock flexible, okay? And when we look at, what we can transform that biomass into in terms of energy and value-added products, so you can split biomass into two general categories. You've got lignocellulosic, which is the hard to process stuff. And then you've got kind of sugars and starches over here. So of course you can use esterification or saccharification to get to biodiesel. Sorry about that. Which slide did I get up to that you could see, please? Was I on this one? Can you all see my slide now?
Yes, we can see your slides.
Okay, all right. So I was just mentioning here that, you know, if we were to compare the different type of bioenergy or, you know, biomass conversion technologies, you can very quickly see that pyrolysis is going to give you, you know, an abundance of different value-added products that, you know, means that you can have lots of different markets or applications that you can tap in a pyrolysis system to, rather than these more restrictive technologies that just focus on one. It doesn't mean you can't use them. It just means they're going to have a limited application when you're looking at a whole country like Nigeria. Okay. Sorry, let me just move this out of the way. Right. So one of the things that, you know, we wanted to find out was that if we were to compare between biomass conversion methods and we were to score these things on, first of all, looking at things like scale. So this is a scale of possible industry, which is dependent on the availability of biomass resource and, of course, which biomass you can use. So in anaerobic digestion can't digest wood, you know, but we can use wood as a feedstock for our pyrolysis system. So that really affects the scale of the technology. And then the feedstock flexibility, of course, you can see the pyrolysis is right up there, you know, direct combustion, as I say, you can burn anything. The conversion efficiency, this is like, you know, how much of the energy that you have does your technology convert into a usable form, you know, so that it's retained in the product. And then you can see that pyrolysis comes out on top if you were to do this kind of simple scoring system. So because of its flexibility and its versatility, it's very well easy to adapt to lots of different settings, which you're going to find in places like Nigeria. Okay. Now, one of the things as well that's really good with pyrolysis is that it gives you as a technology the ability to control the yields of your biomass pyrolysis products. And as you can see here, if you want more char, then you operate at a lower temperature. You know, if you want more gas, you operate at a higher temperature. And then, you know, you've got your organics fraction. So this is going to be useful if you want to produce a bio oil or, you know, biofuel from the bio oil, then you know where you're going to operate. So this means we can tune the output of the technology depending on its application. And you can't really do that without digestion or gasification. And therefore, that's what limits their application. And that's what gives pyrolysis a much wider application. And I'd just like to thank Dr. Judon Woodley, who we've done a lot of research with, and we have ongoing projects with at Aston University, supervised Mohammed's PhD and also taught me, I did my chemical engineering master's. That's where I met Mohammed at Aston University. So, you know, Aston has really led the way on a lot of research. And, you know, that's why I agreed to participate in this event today. Big shout out to Professor Patricia Thornley, who also chairs the SuperGen group. There's some fantastic work that Aston is involved with, coordinates, and really leads the world on, and have some fantastic research facilities and you know, capabilities at the Ebury Institute. Yeah. So, you know, we wouldn't be here today without standing on the shoulders of the giants who have produced a lot of the knowledge on pyrolysis technologies, and a lot of them, you know, have come from Aston University. So thank you very much to Aston and everybody involved. Now, product applications. Let's give you a few examples. Yeah. So here we have a photo of that I took, okay, whilst they're testing this diesel burner that's heating a furnace. And, you know, the price of diesel in Nigeria has tripled, if not quadrupled, since January. And that's creating a big headache for a lot of agri-processors. So they need an alternative to very expensive diesel. And that's where our upgraded bio-oil and it gives these communities in those rural locations an opportunity now to upgrade and export this fuel to manufacturers who might be in, you know, within 100 kilometers of them, and therefore they can fit very nicely into a value chain using a technology that can convert their waste into biofuels. And so that's why we focused on this area as biogenesis. So here's one really, great product application that pyrolysis is very well suited to. Another one, of course, is that when I mentioned, we always produce biochar. And so really what this biochar is in its most powerful form is a carbon, 1 ton of soil sequestered biochar can remove between 2 to 3 tons of CO2 from the environment, So that's really important because you don't get to net zero through carbon offsetting. You only get to net zero by removing existing carbon from the atmosphere. Okay, we can also upgrade the biochar and upgrade it as an exportable organic fertilizer. So we're killing 2 birds with 1 stone. We're helping the people who, the farmers, the smallholder farmers who don't have anything to do with their waste at the moment. We can generate electricity and process heat at the same time as we're producing this biochar, giving them energy access. We can upgrade the biochar into an organic fertilizer because the price of fertilizers has gone through the roof. And then, the biochar hasn't necessarily moved more than 10 kilometers from where it was sourced to where it's then redeployed as an organic fertilizer and then produces carbon removal in the process. To get carbon removal certification, you have to have a process that is, accredited for its, it doesn't put more emissions into the environment. And that's what our system does. You can't just produce biochar that's going to be accredited for carbon removal by doing it in a traditional way. Okay, so there's a whole load of circular economy synergies that are going on here that mean pyrolysis is a very powerful technology. Why is it more powerful than gasification in this respect? Because gasification will only give you about 5%, less than 5% of this feedstock, whereas we can produce sometimes up to 45% of what we put in, we can get out as this material. And this also, therefore, as carbon credits, gives you access to investment. And that investment is then going to pay for the deployment of these technologies in these remote communities who don't have a credit rating. And, no bank's going to finance them to be able to purchase such capabilities. But this is where it fits into our business model. So here's just a little example of the carbon cycle comparison between if you're burning fossil fuels, as most factories or communities are doing at the moment to generate your electricity or your heat, you're taking carbon from a fossil deposit and you're combusting it and putting that carbon back into the atmosphere. So there's a net increase of carbon. If you're doing bioenergy, the carbon, most of it has come from the actual plants, which have removed soil carbon, and then you're combusting it. There's some carbon in the form of the fossil fuels that you're still going to use. And you're hopefully doing carbon cycle and you're putting in your net increase into the atmosphere is less because your plants are reabsorbing the carbon, and it's going around in a cycle. Where we step in is that we break this cycle because we've removed part of the carbon and as biochar. Right, so I just literally finished and I was just sharing my final slide with you, which is just here. If you need to get in contact because there's collaborations that you feel might work with Pyrogenesis, we're always open to collaborating with academics, research institutes, businesses, government agencies. So yeah, by all means, drop me a line. Very happy to speak to you about if you're doing stuff in Nigeria. That's where I'm based at the moment. But we equally have a base in the UK and we're delivering projects in the UK and Nigeria simultaneously at the moment. We have some new projects that we're just about to launch, which will be going on for the next 3 years as well. So by all means, we're all about collaboration. We have led 5 international projects funded by Innovate UK previously. And, as I said, we've just got another 3 new projects, which are also collaborations as well, international collaborations. So thank you very much for this opportunity to speak today, and I'm happy to take any of your questions in the Q&A session. And thank you again to the sponsors and the organizers of this event for inviting us to speak with you today.
Thank you so much, Mr. Simon, for such a brief, such a informative and fruitful discussion. Anyone wants to ask any question? Simon, I have one question for you. Can you please tell me about your success stories? Like you're doing a great job, you're contributing a lot in Nigeria. So how you have some success stories to share with us? I cannot hear
Simon, you are
Simon?
muted.
Sorry, Rick, so I said that you were breaking up a bit there, so I didn't actually hear your question clearly. Could you mind repeating it, please? And then I see Hassan's got his hand up as well.
Hello.
Yes, someone asked to Hassan.
Yes,
Abu Bakr. You can ask your question, please, first.
Okay, yes. Good morning here in Nigeria. My name is Adamu Hassan Abu Bakr. Can you hear me? Sorry.
Yes, yes, I can hear you, Mr. Hassan.
I am Adamu Hassan Abu Bakr, and I work with Advanced Technology Development Institute here in Taraba. It's a center under the National Agency for Science and Engineering. I actually get connected to the invitation on the Zoom, and your presentation actually has made me to actually feel there's a lot we need to actually put in, because I'm living here in Taraba. We have a lot that has to do with a lot of feedstocks deposits, and if your work or your projects could be extended to the northeastern parts of this country, actually where Taraba is. At the moment, I was actually working on a project. It's a personal project anyway. Development of a reactor that has to do a pyrolysis using some of the feedstock we have. So I am intending to actually use rice husks, which we have it in a very large deposit here in Taraba, because Taraba is an agrarian state. So I don't know if you could assist individually people that have interest in developing this technology in this zone. So this is my question. Sorry, thank you very much.
Yeah, thank you very much for your question, Hassan. Yeah, by all means, please use my email that's in my slides to send me your proposal, and definitely look at it and consider it and get back to you with a response.
Okay. Okay, sir. Thank you very much, sir.
You're welcome.
Thank you.
So yeah, Rick, so I was saying that you broke up, and my internet connection was probably the one that was being flaky, and I didn't really hear your question. I was asking if you could repeat it so that I can answer it, please.
Yes, I was asking about your success stories, how you are contributing in the daily life of people like this, especially poor people. Do you have some success stories to show in front of us?
At the moment, the work that we've been doing has all been to develop the technology and identify the applications where we can deploy the technology. The next 3 projects that we have, which are just about to start, are all about the deployment. So we don't have any examples of where our technology has actually been deployed in the real world, so it's actually providing the solution to the real world problems as of yet. Within the next 6 months, we'll start reporting that, through our various social media channels. So by all means, if you join us on LinkedIn, you can look for the Pyrogenesis, LinkedIn page, connect with us, and you'll receive our news feeds that will be coming out. We also have a Facebook page as well, and an Instagram, Pyrogenesis Ltd. Yeah, so that if you want to keep tabs on seeing what we're achieving as we're doing it, we do want to impact base of the pyramid communities, and also the agri-processors who are really struggling because of the massive increases in fuel prices in Nigeria. So those 2 kind of like are our target groups, to go forward with.
Okay, thank you so much. We have one more question.
Yeah, I've just seen a question from Ayoade.
Someone wants to ask.
Yeah, I've just seen a question from Ayoade.
Throw more light on biomass pre-treatment requirements. Yeah.
Sure, that's a very good question.
I'm asking the same question.
Very good question. So pre-treatment methods, you know, I think Dr. Sagir is actually the best place to talk to you about this. So I'd like to invite him, if he's still on the call, to give you some insight.
Yeah, in terms of pre-treatment, I mean, obviously we need to look at what kind of biomass it is and in what form it is. But generally, we need to have biomass which is having a moisture content below 30%. And if it means that we are taking some high moisture containing materials, we may have to naturally let it dry a little bit before we can use it further. But next thing important for us is it needs to have certain sort of size and minimal, if I say, dust particles within the material itself. So a lot of time, if we can chip the material, if it's stem-like material, we can chip it, and those chippings will be best place to go into our system. But if chipping was not an option and material was granular, it could also be used. But if it's very fine material, and in that case, we may have to pelletize it or briquette it to introduce into our system so that we can avoid any high dust formation within the system, because that dust particle together with the pyrolysis gas and the syngas, they sometimes accumulate inside the pipes, and with the bit of condensation, they just build up and clog the system. So hence, to keep the dust and condensation related problems to minimum, we need to either pelletize it or chip it, or use it as in a granular form if it is already of certain size and density. I hope it answers the question.
Thank you so much, Dr. Muhammad Sagir Saab. One of our from our audience, and he's also one of our speaker, Ogin Rona, wants to ask something, or maybe he wants to contribute. You may speak, sir, please.
Okay, thank you very much, Simon and Mohammed, for the very broad presentation, broad but informative. Yeah, especially in the context of Nigeria. Yeah, coupling with what Mohammed presented, the pyrolysis technology and the gasification looks promising in the context of Nigeria. But from your experience, Simon, the little experience you gather in terms of Nigeria, do you perceive a kind of barriers that may likely impede on the penetration of the pyrolysis technology in Nigeria? Do you envisage, because why I'm asking, the political economy in Nigeria is quite different from what you're telling in the UK and Pakistan. So I don't know if you've considered this thought.
Sorry, is that question directed at me? Is that Ogene Ruana?
Yeah.
The reason I'm asking is because my okay. Can you just repeat it? Because I actually dropped off the call there again. My internet is very flaky at the moment. Sorry.
Yeah, my internet is also flopping here because it's currently raining at my end. You may find it difficult to hear me because of the rain. So what I was trying to say that in the context of Nigeria, from your presentation and that the one Mohammed presented, the technology looks promising, especially in the Nigeria space where you have high potential for mini-grid development in the space of agro waste to energy. But what I'm trying to, the question I was trying to ask, based on your experience so far in Nigeria, if you had envisaged some barrier, not necessarily technical barrier, maybe from political economy, because the political livelihood of Nigeria is a little bit complex. I don't know if you've considered that aspect in terms of the penetration of the technology.
Yes, very good question, Ogani Rona. So this is a technology that at the moment, we are having to import to the country. I think that's one of the areas that is the biggest challenge. As you probably know, importing anything into Nigeria has some, significant barriers. Even to clearing your goods from the port is a challenge. This is a new technology that we're bringing it into this country, and therefore we have to go through an extensive registration process. So all of that are the challenges that we're facing. That's why we need the support in order to deploy the technology within the country. Thankfully, we've just secured 2 Innovate UK grant approvals to fund projects that will last for 3 years that will help us to do just that. And this is where I suppose the UK government recognises that there's a need that a UK technology provider, i.e. Biogenesis, can help solve a problem in Nigeria using technology that we've developed. And it is assisting us in that process of bringing that technology to market. It needs cooperation on the Nigerian side, and I'm glad to say that cooperation, we've received a lot of help, especially the NIPC, who is the kind of they're like a government agency that pull together all the different agencies and kind of coordinate actions to say, right, what support does Biogenesis need? Which agencies do we need to speak with? So we are receiving a lot of support, and I'd like to thank the Deputy High Commissioner, the British High Commissioner, who facilitates those meetings. They happen on a quarterly basis to us, so that we get to meet the different agencies that will help to remove the barriers that would otherwise, meet unnecessarily and even not be aware of. So we have received a lot of support. It's ongoing, and hopefully that should help us enter the market. But yes, Nigeria is a challenging market to bring new products into for all sorts of different reasons. It's not for the faint-hearted. Even once we've got through that, there's all sorts of issues that we might meet just transporting the technology from the port to the installation site. As you know, the kind of like some of the roads that you might have to go along are quite, perilous. There's enough situations of, cargoes being lost on the road through accidents or just things overturning and all sorts due to the bad road conditions. So there's a lot of challenges. And so once we have got our system installed and operational, just that in itself is an achievement that's worthy of a lot of interest and showing that we can actually operate in Nigeria. So by all means, register on our LinkedIn page or our Facebook page, keep in touch so that, when we're doing our launch event, you'd be more than welcome to, happy to send you an invitation. We'd like to cooperate and collaborate with academics and researchers and Nigerian universities. So yeah, thank you very much for your question.
Thank you very much, Mr. Simon. We have one more question.
Is this question for us as well? Do we intend to try other forms of feedstock apart from biomass for waste to energy conversion? Yes, in the future. That's from Kelechi. Yeah. So Kelechi, definitely in the case of Biogenesis. I don't know if I'm frozen or if you can still hear me. But yeah.
I think Simon is frozen, so if I can complete answering the question.
Yes, sure.
Yeah, so in terms of waste to energy conversion, obviously waste is generally a mixture of plastic and a lot of other inert and mineralized materials. This means those materials, if we use in pyrolysis technology, as Simon was saying, and produce biochar, then those contaminants may well end up in the biochar. So it's not a desirable route. But these can definitely be used in gasification technology. But currently we have been focusing on clean and kind of pure biomass, so that we do not need any further downstream scrubbing or filtration of some sort. So keep the process steps and the capital investment to as minimum as possible. But definitely the technology is able to use the waste, and mostly plastics give us very good amount and calorific value of syngas in the end. But it also needs a lot of different downstream scrubbing and filtration processes to ensure that we are not polluting the environment and we are not emitting those toxic components into the environment back again.
Thank you so much, Dr. Sajid Saab. Thank you very much. You are performing very well. Any more questions from audience? Ibrahim, do you want to ask any question? It should be a very interactive session. It's not like like a lecturer who is teaching in the classroom. We are all the students and we are here to learn. So all of you can ask questions. Okay.
Okay. Rigza?
Yes, sure.
Yes,
yes,
okay.
We can hear you.
Yeah, just a quick one to advance my earlier question, but this one is from the technical side and is directed to Mohammed. In your presentation, I saw where you mentioned ash melting temperature as a kind of a limitation to some of the technologies. Yeah, but I didn't see where you mentioned high silica content as a limitation. Or are you trying to drive that from the perspective of the high ash melting temperature?
Yeah, so absolutely. I think you kind of answered it yourself. So silica content, again, is linked to the ash melting point of the biomass materials. And yeah, this limits the ultimate high temperature which we can achieve in the gasification system. So normally high temperature is required to convert the tars into simpler hydrocarbons, for example, into carbon monoxide and hydrogen. But if you have ash melting taking place, which means if you are running a bubbling fluidized bed reactor, your bubble fluidization will be affected by this melting of the ash. And obviously you will lose the fluidization. But if you are working in a downdraft reactor, you are again working with the gravity to flow the material down into the outlet of the reactor system itself. And if the ash starts to melt, it starts to agglomerate together and it causes the clogging of the system and your system backs up there again. Our system, which we have developed, it's based on pyrolysis and gasification. It can address both these issues. So we can address the ash melting, and we can also address, for example, limitation in terms of temperature, that we do not take the temperature to such a high limit that where the ash will start melting and cause problem. And even if it did, we have an auger drive system within the reactor which will take it out rather than depending on gravity or fluidization to remove the ash melted components from the system.
Thank you so much, Dr. Sajid Saab.
Thank you.
Or?
Another kind of comment or maybe question for Simon. Maybe Simon, if you can share a little bit more thought on the carbon sequestration potential of biochar and the the economic case which can be built on the biochar or working around the biochar, because obviously with a lot of big global economies going towards net zero, as you said, net zero, it cannot be just met through the carbon offsetting. We need to do some sort of carbon sequestration. So if you can shed some more light on this, it will help.
Okay. Yeah. Can you hear me okay?
Yes, we can. Thank you.
Okay. Let me just see if I can get that slide back up. Yeah, this particular slide. Yeah. Share my screen again. Okay. Can you see my slide?
Yes, we can. Thank you.
Okay. So, yes, what you have is a situation where large industries are typically putting carbon into the environment, into the atmosphere, because in order to generate...
Simon, I want to suggest something. Simon, I want to suggest something. You may turn off your camera, so you may got a stable internet connection. Then we will able to hear you well.
Is that?
Yeah.
Okay. Okay. All right.
Yeah, Simon, carry on. Thank you.
Okay. Can you see my slide again? Can you see this slide?
Yeah,
Yes,
we can.
On process.
Okay.
Yes, we can
Okay.
see your slides now.
So yes, as Dr. Sagir was rightfully saying, carbon removal is, one of the big things that is driving investment going forward since COP26 in November, which I was invited to present at by UKRI. And they made a commitment at COP26. There was a consortium of large organizations, investment houses and all that came together. And they made a commitment of $164 trillion of investment that was going to go into climate change mitigation. Now, climate change mitigation relies on the removal of carbon from the environment. Now, the business as usual case will not achieve what is required by the commitments made at COP26 and previously to try and maintain 1.5 degrees C global temperature rise. We have to remove carbon from the environment. And so that's why we need a carbon negative process. So business as usual is fossil fuels being combusted and putting carbon from the fossil deposit into the environment. Bioenergy, which is great, and this is where anaerobic digestion as well is a bioenergy technology. But it's kind of like still emitting, carbon into the environment. And nobody actually ever talks about the leakages of methane from anaerobic digestion, but they're quite serious emissions, and they're not really being monitored properly at the moment. So as a technology, you want a technology that has minimum to no emissions that are going into the environment. And so when you have, say, bioenergy with part of that carbon that is in the fuel, the feedstock for that energy generation system being converted by pyrolysis, the biochar plays a role in removing the carbon, because effectively plants, if you look at this, let's say this is where plants sit, they've absorbed carbon in the form of CO2 in its gaseous form. They've converted it into their plant material, cellulose, hemicellulose, carbohydrates. When they die, and they return to the ground, they rot in the ground, the microbial activity converts that material back into carbon dioxide and methane gas, which are the greenhouse gases that then go back into the environment. But because we don't allow that plant material to rot, and we've used pyrolysis to convert it into high concentration of carbon in the form of biochar, we've broken this cycle. So we've really reduced the amount of carbon that's going to return into the environment. And that's why we have a carbon removal, a carbon negative system when we do this. Now, if you including BECCS, which is bioenergy and carbon storage, you can even reduce the amount of carbon returning to the environment, which is another project that we're in the process of developing, so that you can minimize any carbon going back into the environment and bring it to almost nothing when you're generating energy. So this is essential in breaking the link between industry and carbon emissions. And it's like people are only just waking up to that there's actually a technology that can do this. A lot of people in industry are completely unaware that there's a technology that can actually achieve this. And that's why, you know, the title of my, presentation, quite rightfully so, is, you know, why pyrolysis is the answer to bioenergy and biofuel production, not just in Nigeria, but anywhere, because it breaks the link between industry and carbon emissions. Okay, I hope that answers the question sufficiently for you.
Thank you, Simon. That was wonderful. Thank you.
Thank you so much, Simon. Any more questions from audience? I think we should move towards panel discussion. Here we got some panelists: Dr. Muhammad Imran, Senior Lecturer, Aston University, UK; Simon Iofes, co-founder, CEO of Pyrogenesis Limited, UK; Dr. Organi Nora, right to pronounce, I'm sorry if I'm speaking this wrong, Senior Lecturer, University of Harcourt, Nigeria; Dr. Muhammad Sagir, CEO, Eco Research Limited, UK. All these are our panelists. So we will move towards our panel discussion. Anyone want to participate? You can ask questions freely. So Dr. Muhammad Sagir, over to you now.
Thank you. I think it will be good to maybe discuss a little bit more about this energy catalyst funding, which is currently the call is open from Innovate UK, and a lot of people might be interested to go for some sort of a joint consortium to apply for this funding. Obviously, my colleague Simon is there on the ground in Nigeria. And we already have a lot of experience working in Nigeria and working with a lot of different partners in Nigeria. If people have some new type of business cases or even technology cases for Nigeria, and especially I'm talking both UK and Nigerian based researchers, please come forward and bring us any new things into light so we can explore further what other things can be done.
You want to say something more?
Is there anybody who is interested to?
Yeah.
Yes.
This Organello.
Yeah, go ahead, Dr. Ogene. Yeah.
Yes, I intentionally switch off my video because of the network situation at my end in Port Harcourt. So please permit me to do that.
That's fine. Yeah, go ahead, please.
Okay.
Okay. Talk about it.
So I actually saw the call for the energy catalyst, and I've shown interest in the pairing of interest group to form a consortium. I think it's coming between 7th and 10th June. I've shown interest in that. So I'm actually interested in valorization of agricultural value chain agri-waste, especially looking at the rural communities. But beyond electricity generation, it's also important to also look at the storage facilities in the rural community. There's a project I'm currently doing with IMRA. It's on using solar photovoltaic and solar thermal to produce cooling hubs for cluster of farmers in Nigeria. We have found out that between the harvest and to the market, over 40% of agricultural produce they are wasted a lack of storage. So it is important that we use locally available resources to develop an energy system that could sustain this rural community. So what we are currently looking at is solar, but I have also seen that it's also possible to use agro waste to generate electricity and at the same time generate a cooling system in a way from drying and also cooling of agricultural produce before going to the market. So the idea is that it's a combined heating, cooling, and heating energy system, but focusing on the rural community, especially the agrarian community, so that they will improve in their income and at the same time minimizing the impact on the environment. Because what they do at the end of the season, they set whatever waste they generated, they set them on fire, and they just burn it like that, and the emission goes to the environment. So we have also done a preliminary resource mapping, which one of my students, Ukoba, who will be presenting tomorrow, will focus on that. So the mapping, we have zeroed on 3 viable agricultural waste that we could use for this technology. Rice, husk, agro waste from oil palm fruits, then cassava. In the South region, Nigeria is divided into 6 regions, but the southern region, their main occupation is cassava and oil palm fruit, and they have them in large quantity. So they just threw them away, got rotten, then during the dry season, they set them on fire. So these 3 agricultural waste could be harnessed to benefit the rural community, while they pay small fees for that. But the business model is another aspect of the game. So we talk of the technology, then the business model. So I think this space could form a research or a proposal that we could put in for the energy catalyst. Thank you, Mohammed.
Thank you very much. Yes, and of course, there are a lot of other activities as well as other funding sources which can also be looked into by these researchers and people who are interested to deploy, whether it's energy projects or projects around general economic development or addressing certain other UN Sustainable Development Goals, and especially addressing the food security. I'm quite keen that if the biogas-based processes have taken off in Nigeria, because I feel that climate kind of is quite good for biogas processes. There is quite high temperature in summer season. There is need for clean cooking. I think some people already highlighted 45 to 55% of the population is not connected to clean cooking or even electricity. So biogas-based processes could be another option, together with the digest state, which can be used back into these farming activities. Is there any development in the biogas sector in Nigeria at the moment, and how do you see if this can take off in parallel?
Yeah, in the space of biogas, there are a lot of research work that are going on in various institutions, but the market presence, I think, is currently low. But I think the reason why it's so is that they have not been able to develop a small scale or household scale biogas energy converter. If such system is available, then I think it would be nice to drive it out. And that will significantly drive the biogas energy space. As Simon rightly mentioned, one is to produce the biogas. If you produce in a very large scale, you need the facility to transport it to the local end users. So that one is another issue. But if it comes in a very small household-based energy or bioenergy converter, I think that will be accepted quickly than kind of a community scale or large scale process. But on the whole, there are work going on in biogas generation from the research side. But there are also small couple of businesses around that, but it's not widespread in the country as I speak.
Right. Okay. Good. And obviously, the Rural Electrification Agency is working quite actively to deploy a lot of these electrification projects throughout the country. And I see that solar energy is kind of becoming quite popular everywhere, really, not just in Nigeria. But there remains the problem of obviously 24/7 availability of energy. Energy storage is another issue. Lack of local energy storage devices is another problem. So are there any kind of companies, or is there any momentum where solar and biomass energy can be integrated to address those issues?
Yes, there are many existing companies around town. Also, there are you mentioned key areas, but there's another area I think you didn't mention, local capacity to drive the mini grid from solar. There is high shortage of manpower to drive that, because the mini grid is growing exponentially, but the capacity in terms of human capacity to drive it, they are still looking at foreign intervention. So that is why at the University of Port Harcourt, we established an MSc program on energy access and renewable energy technology. So one of the mandates of that program is to produce a local, high-level local capacity that will drive the energy access sectors from all aspects, electricity, gas, and the other aspect of energy. Also, climate change mitigation technology. So we have established that, and we have the first cohort now. And the way it's structured, after in-class learning, they have 3 to 4 months to have an industry experience. So the level they are now, as from next month, they will be going for internship, where they see what is the real world thing that is happening, and trying to develop, when they come back, they develop solutions which form their end of program dissertation. So, but it's real life problem that they will solve, and near market solution that they will be start rolling out. So, however, this program and some other thing they have in mind also needs funding. So that is the current issue that we are having at our end. But there are also mini grid companies around or within Nigeria. They are into mini grid development and the rest. Thank you.
Thank you. So, so the funding to run such training courses to develop local capacity, whether it is for thermal power generation or solar power generation, and also the design and fabrication, installation, commissioning, operational capacity within the country. I mean, what do you think? What is missing? Because obviously there is funding element, but there is also lack of policy development from the government itself, maybe perhaps local institutes not taking it so seriously that there is a capacity gap and this should be addressed. I mean, are there any developments in this sector? How do you see? Obviously, you said your university or one of the university has set up such a course, but I think there is a need for similar courses to be set up and running in the country. Obviously, with the solar coming in, and there is a lot of funding now channeled towards Nigeria, all these need to be supported somehow, isn't it?
Exactly, they need to be supported. And one thing we should also put in mind is that using direct technology from outside the country without putting the country into perspective in terms of local variabilities will not work properly. So that is why it is important to train local people that will handle some of these things, but their solution will be targeting the local community with inherent local variabilities. So, but the policy, there are huge positive policies there, but there are in terms of implementation, there is another ball game altogether. There are good policies from what I've seen, good policy that could support mini-grid development, but the implementation is another issue. But in the area of skills and competency, it's actually lacking. In fact, before we started the program, we did a need assessment by assembling some of the mini-grid developers in the country. Hello, can you hear me?
Yes, we can hear you.
Okay. So before we started the program, we did a kind of a need assessment by assembling mini-grid developers and critical stakeholders from the academics, industry, and the policy. So we converged at the University of Port Harcourt. It was after then that we started rolling out the courses and the course content, which aligned with the skills that they identified that were lacking in Nigeria. So, but in the training, we involve people from Nigeria and also from outside the country. We had people from the UK, from US, Australia, Netherlands, that are actually teaching the students here. But the funding to support the program is another thing. At the cost of establishing it, the UK government actually supported it, but just for the roll out the program. But to run the program beyond that is not part of it. But recently we had just more funding from Liechtenstein Institute of Sustainable Technology that supported five students in the program. It's kind of scholarship. So that is where we are at the moment.
Okay, thank you. And in terms of local, obviously, technology development and local solutions for local problems, lowering the production costs of systems, job creation, and so on, and developing entrepreneurial capacity of the people. Obviously, a lot of these agricultural-based energy systems can be quite crude and locally produced and deployed. Is there any momentum in things like biogas or combustion-based systems or biomass pre-treatment in terms of briquetting, pelletization, and utilization of these compressed fuels in existing thermal energy systems? I mean, is there any drive on these?
Please, I didn't get the question correctly. A call was coming to my phone, and I was using my phone as hotspot.
Yeah. Okay.
I don't know if you can repeat that.
Yeah, I was saying that obviously, I mean, Nigerian people are very smart, and I mean, they understand what the problems are. A lot of time people try to help themselves and locally develop some of these technologies. They may be a little bit crude, but they work, and they can be low cost. So things like pelletizing the biomass or briquetting the biomass or using some other form of biomass in biogas systems, these things can be done locally. I mean, is there any momentum in local technology development where people are helping themselves to actually develop low use cases or some sort of not so highly sophisticated and advanced technologies, but there are still a lot of technologies which can be developed locally? Is there any interest locally people are helping themselves?
Yes, they are. They are, especially from this anaerobic digestion, as I said, from the universities. Then gasification, biomass gasification. They also do that. I think one of the professor at the University of Port Harcourt, let me just check if he was here, and he actually asked you a question. He's also working on bioshare development. I think one of his students is working on that. Yeah.
Yeah, it will be good to know their comments, because I think there are a lot of things which can be done or being done in Nigeria. So it will be good to hear about other people's perspectives.
Yeah, they are scattered across the country.
Mohammed, I think there's, sorry, if I could just interject there. There is not so much in the bioenergy space, but definitely in the refinery space. Unfortunately, we've heard about just such kind of like local processes. So this was like, there are these kind of bush refineries, and in the news within, I think it was the last 2 weeks in Nigeria, there was a huge explosion and a lot of people, over 100 people killed as a result of what was like a bush refinery that they were tapping the oil, the crude oil pipelines and then refining it themselves. So there are people who are developing refineries here in Nigeria, building them locally made. But unfortunately, because of the lack of safety culture or, engineering design that goes into these things, they can have, calamitous results, catastrophic results. So if it's, depending on how complex the system is and how dangerous the process is, I think there's definitely there's definitely people who are, doing some very interesting things, but there has to be the right kind of levels of control. So if you've got a process that isn't flammable or explosive or whatever, then yes, I definitely recommend this. There's probably really good capability here. It just needs to be harnessed and supported. But where it is like quite a dangerous process, I think there should be discouragement of actually trying to do that, because you and I have worked in those type of environments where ATEX and COMA and all these type of safety cultures are essential to avoiding incidents. But that unfortunately might not be the case here in Nigeria, where you do have people that are literally building refineries and operating them without those kind of safeguards in place. So there's positives and negatives, I think. On our side, I mean, what we've seen is like, I think one of the areas where there's a lot of opportunity is in something like Gary processing, because one of our projects was we did design an improved Gary fryer system that could use the process heat from our system. And that would then create less deforestation, because there's a lot of firewood or charcoal, which all drives deforestation, that is used to power Gary frying, or provide the heat, the fuel for the heat for Gary frying processes. And that's what most of Nigeria's cassava, and Nigeria is the world's largest producer of cassava, currently ends up as a staple food. So I think there's a lot of scope. We've worked with the Federal Institute for Industrial Research, Oshodi, FIRO, and they work with a number of universities. But I think there's more collaboration that could happen if we got some of the universities that have good engineering departments and good training programs. So I'm really encouraged by what I've heard Ogene Ruana say, that to kind of forge collaborations, and this is something that I'm actively looking into at the moment. You know, we've recently signed an MOU with with an organization that coordinates the agri-processor sector. I don't want to say more at the moment because we haven't had a press release to mention, you know, who they are. But I think anybody who's on this call that is part of an institution that has capability and capacity that wants to come together as a consortium, there are all sorts of additional funding streams that could support developing, you know, capabilities that are going to effectively, you know, feed into the value chains of, you know, this whole bioenergy sector. So yeah, by all means, get in touch, please, via LinkedIn or however.
Thank you.
Thank you, Simon. Is Dr. Imran still online? I mean, it will be good to know about your project. What's next from your project? What is happening? And perhaps you might be working on an Innovate UK application. And is this going to go big? Are you scaling up? What are the developments there? You there, Dr. Imran? Okay, seems like maybe Dr. Imran is not online or is busy somewhere. But I see that the project which they have done in terms of utilizing the waste heat as well as using the solar for heating and cooling, it sounds very interesting and relevant to build upon through Innovate UK funding and do another phase of that, perhaps scale it up. But also, I mean, as Simon highlighted, there are potential for energy and agriculture integration where we are not just utilizing the agricultural residues, but we are using agricultural residues to produce the energy for agriculture related activities. For example, farming activities where, for example, gari is fried or processed into a flour, there is heat and power requirement. Those processes can be supported from the cassava waste, for example. And similarly, a lot of other processes, date palm oil industry can materialize on similar activities. But I think that there is huge potential for integrating energy and agriculture together to address the sustainability, to address the food production, lowering the food production costs, making food self-sustainability, self-sufficiency within Nigeria. All these can be addressed from these very technologies, gasification, pyrolysis, biogas processes, even solar. But the only problem with solar is if you don't have storage, then you are kind of dependent on some other form of energy to run the processes for 24/7. But if you're only working during the day, it might help. I think if there are any other questions, any other people would like to comment on anything, I would like to invite those people. If anybody wants to say or add or comment on anything else.
Yeah, thank you, Muhammad. You know, I was mentioning Professor Kuye. He actually dropped out, but he has joined the room now. I don't know if he has something to say about, especially the gari frying that Simon mentioned. Right. He's actually working on gari frying process using solar energy. So, Professor Kuye.
Dr. Sagir Sab, we have one question from audience. Anthony, you want to ask something?
Okay, so let's see that
Anthony, you may speak, please.
Okay. Hello, everyone. My name is Anthony.
Yes, Anthony, we can hear you. Please speak up.
Of energy access and renewable energy technology. And I would say that the program has been successful.
Your voice is too low at my end. Dr. Saghir, can you hear Anthony?
No, I think we have some mic issues. Can you correct your mic and try to speak up a bit louder, please, Anthony, if you can?
Yeah,
Okay.
failing that, I'd recommend that if Anthony could type the question. Could I just interject at this point as well? Because I mean, one of the key things that's really important in everything that we're doing to try and develop this sector, gender equality and social inclusion is very high up on the, on the list of things that we need to ensure that we are addressing. So I'm very interested, especially to hear from people who have been working in this field, of their experiences of how gender equality and social inclusion, what you've seen that has been effective. I know operating in an African setting and feedback that we've had from some of our partners that we've worked with previously was that one way of addressing, for instance, gender equality was that by where they recruited all female technical teams because they found that actually having mixed gender teams actually didn't, created all sorts of, there was a lack of support and there were unexpected pressures that women were exposed to that meant that they weren't very good at retaining women in those technical roles. And then there was also communities, biases against women in technical roles. So understanding the dynamics of, what creates barriers, especially for women in technical roles, it is something that we would like to learn more about. We've done research on, and the research that we've used and deployed was in our recruitment processes, just even the language that we use, using gender neutral language, for instance, and also using imagery that shows women in technical roles in the jobs that we're seeking to recruit to. I'm interested to hear from anybody who's on this call, if you've got other kind of like experiences that you have of positive or negative situations that will increase our awareness of how to improve both gender equality and social inclusion. We mustn't leave out the benefits to groups that are currently not having access to these opportunities. Thank you.
Yes, very well said, Simon. Thank you for that addition.
Thank you so much, Mr. Simon. Anthony, you may ask your question, please.
Okay, thank you.
I think Anthony got internet disruption. Okay, Dr. Saghir sir, have you done from your side, or do you want to say something more to our audience?
I think, Anthony, if we cannot actually hear you, your voice is very, very low. If you write your question, maybe we can address that. But I guess you might like to add more than a question and make some comments, which we welcome, but we are not able to hear you properly.
Okay, thank you. I'll send it.
Yes, please do. Thank you. Okay, so I think, Ogene, I think you said there was somebody here, Dr. Okoye.
Professor Kuye.
Yes, sorry.
I think he has gone out again. The network has been very bad. Yeah, I think he has gone out again.
Right, okay. It seems like internet is not very good today out there.
I think this is actually it's indicative of one of the other challenges that we need to overcome.
Yeah.
It's not just the provision of electricity. We have to have the provision of stable and reliable internet connection. Because yes, you know, communications, modern communications, I think COVID really proved to the whole world that we can actually do things remotely nowadays. We don't have to be physically present. And so communities that had access to stable, reliable internet connections, you know, could still work. You know, a lot of people worked from home. You know, my entire team, we went from 3 people to 13 people during COVID. You know, we grew as an organization and we hadn't met each other in like 9 months. So, you know, these are one of the challenges as well that we need to be figuring out ways of addressing. Now, for us, when we install one of our systems, we need to monitor that system, and to monitor that system, we need an internet connection. So making that or sharing that internet connection with a community, a rural community, is going to be a way of not just providing them with electricity access, but also access to an entire global, you know, market, audience, information, you know, and education. So I think education is really key, and it taps into what Ogeni Ruana was saying about, you know, having access to courses. I don't know if there's any plans for courses that can be delivered that are, you know, online courses, you know, so that people can still maybe access some form of training via the internet. And then also what can be done to improve internet connections as well.
Excellent.
Yes, yes, definitely.
Okay, here is my humble request to all audience. Can you please turn on your camera just to click one picture, so we may be able to create a report of this workshop. Thank you, Simon. Thank you. Thank you, everyone.
Okay, I think the people may not be able to put their cameras on. Okay.
Seems more interactive now.
Yeah. It's also our personal choice. Not everybody might want to put their cameras on. You know, with remote working.
Anthony still wants to ask something. Anthony, please speak up. We are waiting for you.
The other thing to point out is that with remote working, it's not always actually appropriate to have your camera on. You never know what situation people are currently in, and where they're having to present from. Especially if you happen to be in your car and driving through traffic, which I've also had on one of these calls in the past. Keep your camera off in that instance.
Dr. Sugi, can you take a screenshot from your side as well?
Sorry, say that again, please.
Can you take a screenshot from your side as well?
Yes. Okay.
Your laptop. Thank you.
Okay. Can you hear me?
Yes, Alfred.
Hello.
Hear you.
Oh, thank you. Mine is not particularly a question. It's more like a comment on the session. I've been here from the beginning, and I must say that it has been really interesting, especially hearing the presentation about the technologies coming on board in Nigeria and also in Pakistan as we have it. I'm an MSc student at the University of Harcourt, the MSc Energy Aspects and Renewable Energy Technology program, and currently, I mean, these kinds of events are going to help me in particular expand my knowledge on what has already been taught. And especially as I go into cases period, it gives me an idea of the need assessment or the need areas to focus my thesis. And I must say that's been really interesting. I look forward to more engaging moments like this. Thank you for the interesting conversation here.
Thank you.
Thank you so much for your comment. Thank you. Dr. Khalid, do you want to add something? Dr. Khalid, are you
Hello?
there?
Sorry, I didn't get that clearly.
Yes.
I didn't get what it says clearly.
Alfred, I'm unable to listen you well. I'm unable to understand. You please write a question, or what you want to say, just write in box. Dr. Khalid, you are muted, please. Again, Anthony, welcome.
Hello.
Yes, we can hear you.
Okay, thank you. The network has been really challenging, but I'm glad I'm here now. I want to thank the organizers and presenters for the wonderful knowledge that has been shared today. And I also want to say that I believe and that awareness and sensitization of the general populace, even the government organs that are involved in policy formulation and also acceptance and driving these policies is key to using renewable energy solutions in this country, in Nigeria as a whole, because from what we've seen, people still don't know the advantages of renewable energy solutions and how easy it is for us to deploy them in solving the energy challenges we have in the country. So I also want to ask, is there anything that is being done that can help in deepening sensitization and advocacy for renewable energy in Nigeria? Partly because my company, Tony Pash Energy, is involved in this advocacy. We have the Sustainable Energy Talk, which we've had 2 editions so far, and the turnout and the questions people ask, it still shows that there is a long way to go in informing people and sensitizing people about how these renewable energy solutions can actually solve the challenges of energy we have in Nigeria. Thank you.
Thank you so much, Anthony. Again, Your Honor, Dr. Muhammad Sagir, Simon, do you want to say something more, or do you want to say some key points of this workshop? So we may wrap up now. I think we are getting late.
Well, I don't think I have anything else to add, but I would like to thank all the participants, organizers, and especially Dr. Imran, who was the reason for us to connect together here. And let's hope this is just the beginning of another, hopefully, or many other workshops in future, and we will enlighten ourselves, we will exchange our knowledge, and we will learn from each other in future. Thank you.
Thank you very much. Thank you very much, everyone, for participating in this workshop, for sparing your time out. I want to formally thank you, Dr. Muhammad Sagir, Dr. Nirwana, Simon, Ioface. All of you did very well job. You are doing great job and you are contributing a lot in the society. I want to thank you, all the audience who are participating and who did comment in this workshop and session. Thank you so much, everyone. It's a time to wrap up. Again, inshallah, next time we will see again each other, maybe tomorrow. Tomorrow there is another workshop. Dr. Muhammad Sagir, do you know about that?
I am familiar with that, although I'm not sure if I will be attending all of it, but I will try.
Okay, thank you so much.
My colleague, Dr. Mohammed Zigis, will be presenting, and he's going to be, giving a discussion about the application of remote sensing data and techniques to crop type mapping, growth monitoring, harvest detection, and biomass waste estimation. And this was a capability that when he was doing his PhD at University of Leicester, he worked on our Energy Catalyst Round 6 project called Pyropower Africa. So with Professor Kevin Tansey and a team of other researchers at University of Leicester, they developed some very good geospatial mapping tools for us that mapped bioenergy resources in Nigeria. So definitely, I'd recommend it will be well worth, if you want to know where the biomass is and how much of it there is, his presentation will be well worth watching. So that's my colleague, Dr. Mohammed Zigis, who will be presenting that tomorrow.
Thank you so much, Simon. I'm again inviting all of you for tomorrow's workshop. Our topic is focusing on biomass estimation. So if you want to connect it about latest technology, you want to learn something more, so please join us by tomorrow. Thank you so much. Allah Hafiz.
Yeah, a final comment. If any of you are happy to share your WhatsApp numbers, please do so in the chat so that we can create a group. And Dr. Khaled is quite keen to set up this group to keep us connected in future.
Yeah, sure.
Thank you, everyone.
Thank you.
You'll have to leave the session open for a little while, Rixa. Otherwise, all the numbers will disappear.
Exactly. Yeah. Thank you, Simon.
And I'm presuming that there's a +234 in front of those numbers that are Nigerian numbers. Yeah.
Yeah.
By all means, feel free to connect via LinkedIn as well.
Sure. So, Rixa, please leave it open for another few minutes until people copied these numbers, or at least you have the ability to copy them to create the group.
Yes, I'm doing that. I'm doing that. Don't worry.
All right, excellent. Thank you very much. So I'm sorry, I'll have to disappear, so I'll leave you to it.
It's okay. It's okay.
Thank you, everyone.
Take care. Bye.
Yeah, bye-bye.
Bye-bye. I'm just taking the numbers. If someone want to leave, you may. I think everyone is done. Okay, see you again, audience. Allah Hafiz.